Hello, my name is Rustem Ovanov. I am going to introduce all the topic estimation of energy efficiency of the data processing center by the method of PUE. The demand for data centers, which consumes a large amount of electricity, is growing with the growth of digitalization and the accumulation of big data in the network. The energy consumption of the cooling system for the machine room accounts for a significant part of the operating cost of the building. Pre-cooling in a refrigeration system reduces energy consumption much more than operating systems with a vapor compression cycle. Today, the main problem of energy consumption in a data center is a functioning of the ventilation and air conditioning systems. Since the network and server computing equipment located in the computer room of the building, when processing and calculating information in the 24/7 365 mode heats up and is a source of heat surplus. Solving the problem of reducing power consumption by refrigeration systems is very important, since according to the global industry, a rapidly growing data center will consume 4.5% of the electricity generated worldwide by 2025. For comparison, in 2010, this figure ranged from 1.1% to 1.5%. It means 325 billion kilowatt. The article deals with the analysis of methods of assessing the energy efficiency of data centers according to the PUE method. Compression of cold generation obtained in a vapor compression, refrigeration cycle, and free cooling cycle for data center. With the advent of the green energy trend in the data center industry, the power usage effectiveness has been applied to access environmental friendliness, the energy efficiency. The PUE formula is as follows: total facility power for IT equipment power. Reducing PUE is mainly achieved by installing the free cooling system. The principle of free cooling is based on a heat exchange in a heat exchanger without mixing the outside and inside air. Generation of cold obtained in a vapor compression cycle based on the process compression, condensation, throttling, and evaporation. Today, we following types of free cooling are used: chiller with free cooling, direct free cooling, indirect free cooling with or without adiabatic humidification of the outside air. Chillers by installation type are monoblock with a remote air condenser with a water condenser based on dry cooler, combined with free cooling function. Free cooling chillers are larger, heavier, and more expensive than conventional vapor compression chillers. However, the high energy efficiency of a free cooling chiller is achieved by shutting down the steam compressors during the cold season and benefits from energy saving at the end of the payback period, since that steam compressor consumes of 19% of the total electricity consumption of the entire system. For chillers with a free cooling system, several operating modes can be distinguished. One of them is the machine cooling mode, when the outside temperature does not allow the column temperature is dropped below the required column temperature. A transient mode is processing when the outside air temperature ensures the column temperature drops below the required column temperature, but at the same time 100% of the cooling capacity is not yet ensured due to the free cooling. Free cooling occurs when the outdoor temperature drops the column temperature below the desired column temperature. 100% cooling capacity is achieved by the free cooling and the chiller compressor stops. The system goes into free cooling mode. Results of the study. At the design stage of the free cooling system in a data center, one of the main parameters for choosing an energy efficient solution is a payback period of this project and value of the annual energy saving. To estimate the payback period, the formula is used. As an example, the calculation of the payback for a free cooling system or installation in a computer room, consisting of 4 rows and 13 server racks each, 52 server racks in total, is given. The machine room is located in the city of Almaty of Kazakhstan. Each rack contains 15 servers with an average power of 400 watts. Since the heat dissipation of IT equipment is equal to its power consumption, the heat surplus of each rack is 6 kilowatt. Then the knowledge of the total heat dissipation of the equipment will be 312 kilowatt. Required cooling capacity 312 kilowatt. A monoblock chiller with and without free cooling system was taken as a refrigeration machine. The payback period for a monoblock chiller with free cooling for Almaty is 2.7 years. In regions with temperature and cold climates, the availability of free cooling helps to significantly save the amount of electricity in the autumn-winter period. In a dry cooler, only axial fans are powered, while in other types of refrigeration units, electricity is also required to operate the evaporator. Conclusions. To improve the energy efficiency of the data center, free cooling systems should be introduced at the design stage. When implementing, planning, building a data center to improve the power coefficient, one should take into account the climatic characteristics of the environment, of possibility of using renewable energy source and rejection of the energy-consuming vapor compression refrigeration cycle in favor for more efficient cooling systems based on chiller-free cooling.